we'll be presenting on low flow, high efficiency, everything you need to know about drip irrigation. On the agenda this morning, we will quickly run through the basics of low flow drip irrigation and a bit of drip irrigation in general. We will take a look at water distribution test results and also why this is important in the planning phase of your new developments to make an informed decision. We will quickly run through the system design of a typical low flow irrigation system and then a summary. So we have quite a bit to get through, even though it doesn't look like this at the moment. So let's get going. So when we talk about drip irrigation, we talk about efficiency. Drip irrigation is all about efficiency, and this is because we have minimal losses to the atmosphere. It is not necessarily that the tree uses less water. It is because we are applying the water very efficiently. We do not have evaporation from the soil surface, or we have minimal evaporation from the soil surface. And we also do not have the wind factor that influences the water distribution as you would have in an overhead system. So this is why we say drip irrigation is the most efficient irrigation system. We also have efficient uptake of the water by the roots as well as the nutrients by the roots. And this is because we apply the water and the fertilizers directly to the root zone. So the tree doesn't have to work really hard to go and look for the water and the nutrients. We're already applying it directly in the root zone, and this is where the tree can take it up effectively. We also like to think that we make efficient use of labor, because this is a system that is very easy to manage. One guy can irrigate or can manage a large area at once. There's minimal maintenance on these systems. So we would like to say that we use our labor very efficiently as well. And at the end of the day, I think the essence of drip irrigation is that we are constantly trying to grow more with less, using the minimum amount of inputs and still getting the maximum amount of output in the form of yield at the end of the day. So the days have long passed where we were only talking about drip irrigation as a system that only delivers water. There was a time where soluble fertilizers was also a new thing, and now these days we can deliver fertilizers, chemicals, organic fertilizers even through the system. So it's a very versatile system. We like to think of it as a delivery system. Some of the new stuff that's being tested at the moment is applying things like herbicides, pesticides, nematicides, even some hormones like ethapon are being tested through the drip irrigation system, and we are doing it very successfully at this stage. I would take back testing. We already finished most of the testing on these things. We are already applying it successfully, and that is why we refer to these versatile drip systems as delivery systems instead of just thinking of it as an irrigation system. If we zoom into drip irrigation a little bit more, in the old days, there was basically two approaches that you could have followed. First of all, in the top picture, you can see there, we talk about strip wetting. So what this means is that the drippers would be typically spaced closer to each other, and we would wet a continuous strip all along the tree row. The other approach was a pot wetting approach, and this is typically where the drippers would be spaced further apart from each other, and we would feed the roots of the tree with water and with nutrients within that pot. And you can clearly see the roots concentrating below that dripper, and we localize the roots and we feed it with water and with nutrients in that pot. And both worked very well for a very long time. And I would say now for the past few years, and it's been almost 5, 7, 8 years now that we are busy with continuous low flow drip irrigation. And this is where I'm going to stand still for a bit today. So what is considered to be low flow? So according to us, low flow is drippers with a delivery rate of 1 liter an hour or less. I know my colleague Jerry Austin did an excellent presentation yesterday on the workings of a dripper. So this is just another picture of what it looks like on the inside of a dripper. On the left-hand side, we have our Uniram range, which is the top of the range, the exclusive dripper for orchards. And on the right, we have DripNet PC, which is also a pressure compensated dripper, which we use more for the sugarcane and the maize industry. What I would like to point out at this stage is, if I can just switch on the pointer, is if we say that drip with a delivery rate of 1 liter an hour or less, we basically have two options. We have the 1 liter an hour Uniram dripper, and we also have the 0.7 liter Uniram dripper, which is the more popular one, I must say at this stage. I would also like to show you here that if you can take a look at the flow path of these drippers, that the 0.7 and the 1 liter, which is the low flow drippers, have a much narrower and smaller flow path compared to the more traditional delivery rates that we have. And I'm saying this because we need to be aware of maintenance when it comes to these drippers. It's not something to be scared of, it's just something that we need to be aware of. And I just wanted to show you how it looks like on the inside as we continue. So if we talk about continuous low flow drip irrigation and we need to put a definition to it in words, it would probably go something like this. We want to balance the application rate of the irrigation system in millimeters per hour or in cubic meters per hectare per hour with the maximum daily water use, which is the daily water requirement of whatever crop you are planting, over the total consumptive period of the crop, which is transpiration hours or sunlight hours. And I know this sounds like a mouthful and it's a bit difficult to understand at first glance, but I am going to elaborate a little bit on this. Because for me, this is the slide that basically sums up low flow drip irrigation. So what we are trying to create within the root zone is we are trying to simulate optimal conditions in the root zone throughout the sunlight hours of the day. Why are we trying to do this? Because we are trying to create the maximum potential for the tree to produce a good crop or a good yield at the end of the day. And how do we do this then? Is we simulate the optimal conditions throughout transpiration hours, because the tree transpires throughout the day with sunlight. This is the factory pumping up all the water and the nutrients. And we want to have the optimal conditions the whole time throughout the day. Let's say from 6 in the morning till 6 in the evening for argument's sake. So you might ask at this stage, what do we see as optimal conditions? It is a good question. Optimal conditions for me is the correct ratio between soil, water, nutrients, and oxygen. So this ratio will obviously differ between different crops, different phenological stages, even different soil types. But if we can hit that sweet spot of correct water, nutrients, oxygen, and soil, then we can have optimal conditions for the tree, and the tree can reach its maximum potential at the end of the day. I hope this slide makes sense. If we take a look at continuous low flow in a graph, what would a typical day look like? On the y-axis, we have the application rate of the system, which is this horizontal line that runs here. This stays constant throughout the day, and this will be something like 2.5 cubic meters per hectare per hour. We have the bell curve is the water demand of this crop. And then on the x-axis, we also have the time of the day of irrigation. So if we switch on the pumps in the morning, the tree is still busy waking up, the stomata is busy opening, it's still cool outside. At this stage, we are oversupplying the tree with water because the tree cannot use all the water that we are applying at this stage. When it gets a bit hotter at about 10, 11, the tree is in the full swing of things. The factory is open, all the stomata is open, the tree is busy pumping water. The application rate stays the same. At this stage, we might say that we are under irrigating a little bit of what the tree can use at this stage. And then at the end of the day, when it's cooling off again in the afternoon, the stomata is busy closing up. We are still irrigating at the same application rate, of course, because this stays constant. One might say that we are oversupplying the tree with water. One thing that is important at this stage to note is that the over-irrigation in the morning and the over-irrigation in the afternoon should at least be equal to the irrigation shortfall that we experience in midday. But in most cases, the over-irrigation in the morning and in the afternoon is a bit more than it is in the midday. And yes, this is very important, and we can also monitor this. So this is not just a nice graph that we put up. We actually monitor to see what the tree is busy using. We do this with tensiometers, with capacitance probes, with pressure bombs, dendrometers on the tree trunks. So we actually measure to see if this really is happening, and we can confirm that this is mostly what is happening in the orchards during the day. So if we take a look at the disadvantages of low flow drip irrigation, first of all, the flow path is much smaller, as I already showed you in one of the previous slides. And like I said, there's no need to worry about this. We know how to treat it. You just need to be aware of certain prerequisites that need to be in place when it comes to maintenance. One of them is the continuous peroxide. So every time we start the pump, there's a continuous supply of peroxide that we apply through the system at a very low concentration, 5 parts per million, up to 7 parts per million in cases that the water needs a bit more. But it's not a lot of peroxide that we do, and we do this because we want to keep the system clean from day one. We don't want to experience a problem in 2-3 years' time and then start treating the system. So we rather keep it clean from day one. Other thing that becomes important is regular flushing. This is important in all drip systems, not only low flow, and this all depends on your water quality. Of course, the worse the water quality, the more often you will flush, and the better the water quality, the less often you have to flush, but you still need to flush. I would say normally a normal drip irrigation farm with average water quality would flush around every 2nd to 3rd week. They would flush their laterals. We also recommend that you use disc or sand filters to filtrate the water, and we also recommend that you filtrate at about 100 microns. My colleague Leon Horn will do a presentation tomorrow on filtration, so be sure to tune into that. I'm sure it will be very informative. If we take a look at the advantages of low flow drip irrigation, first of all, we have longer hours per shift without irrigating past the root zone. And this prevents the leaching of water as well as fertilizer past the root zone. Now, this is a very important point because this is where low flow, where the trend started going to lower flows. Because what we saw is in the old days, with the higher flow drippers, 8 liter an hour and 4 liter an hour drippers, the guys would irrigate for even less than an hour, and then we would see the water go past the active root zone. And it would leach out all the water and the fertilizer past the root zone, and we would be very inefficient with our irrigation. We would waste a lot of water past the root zone. Now with the lower flow drippers, we can irrigate for a longer time and still stay within that root zone. It's again that sweet spot that I talked about with the correct balance between soil, water, nutrients, and oxygen. Now we can keep the fertilizer and we can keep the water in the active root zone for longer without leaching away all the nutrients and all the water past the root zone. So this was the initial trend for going to lower flows, is to keep all the water and the fertilizer in the root zone. We also can wet a wider wetted area. I'm going to elaborate on that when we come to the distribution and the results. Again, we improve that soil-water-air relationship. We never oversaturate the soil. There's always a bit of oxygen in with the nutrients and the water, the sweet spot that I talked about. Some say it's cheaper because of smaller infrastructure, because the flows are lower, we use smaller pipes, etc. I'm not going to talk too much about that today. And we can irrigate large areas at once. Because the flow is so much lower, now we can all of a sudden irrigate a larger area. And this is more a management benefit than it really is an agronomical benefit, but still a massive benefit. And we will talk about that in the design part of the presentation this morning. So now we get to the water distribution test results. First of all, at this stage, I would like to say, why is this important? So for us, this is really important to test your specific soil on your specific farm in your specific climate. No two farms are the same when it comes to the water distribution below the soil surface. And we as a team at Netafim can help you make an informed decision while we are still in the planning phase of a new development by just doing a couple of simple tests to see what specific combination of delivery rate dripper with the spacing of the dripper will be exactly suitable for your specific conditions on your farm. So let's jump into before we jump into the results, a little bit of theory first to better understand the results. When it comes to water distribution below the soil surface, there are mainly two forces at work. The first one is gravity, and this is the same force that keeps us all on the ground, our feet on the ground. This is responsible for the vertical movement of the water below the soil surface. The second force at work is the capillary action, which is responsible for the horizontal movement of the water below the soil surface. So in theory, a lower flow emitter will allow the soil the chance to make use of its own capillary action to distribute the water more horizontally versus vertically. So again, it's a mouthful, but let me try and explain a little bit better. Is that if we deliver at a very low application rate, we give the soil the chance to move the water horizontally through the capillary action. So then the capillary action takes preference over the gravity force at work. If we apply the water, like I said, in the old days with a high delivery rate, drippers, 8 liters an hour, we're constantly putting down water at a very quick tempo. It just pushes down the water. We never give the soil the chance to really move the water horizontally and get a nice wide wet area. The soil texture also plays a major role when it comes to the distribution in water. And this is why we do this test, is to see how your specific soil reacts. But if you just take a look at a simple example in the right-hand side of the corner, you will see that on where the pointer is now, we can take it as a heavy soil. It's a clay soil, let's say 25% clay plus, and we would typically see that we can wet a wider area, but a lot shallower. This is where the capillary action again is the preferential force in the soil because of all the micropores that we find in clay particles, between clay particles. In the middle, we will find a nice loamy soil, I would say somewhere between 15 to 25% clay. And this is when we see what we call a 1-to-1 width to depth ratio of wetting, a very nice wetted pattern. On the right-hand side, we would have a sandy soil with 10% or 15% less clay. And what we would typically see there is that we have a much narrower wetted area, but we wet much deeper, and because gravity again is the biggest force at play here. So this is just a bit of theory about how water distributes and why water distributes below the soil surface. If we get to the actual tests that we do, and at this stage I think it's important to mention also that when you do the tests, it's important to do them after soil preparation as the orchard would be just before planting. There's no use in doing the tests next to the side of the road. The distribution will not be the same next to the side of the road as it would be on a ridge after soil preparation. And this is really important because we want to get the exact picture in order to make an informed decision about what irrigation system, or more specifically, what drip irrigation system will be suitable on your farm. So on the right-hand side, if we can start on the right, we have our first treatment. In these 3 buckets, we will have 9 liters of water, and we will have a 2 liter an hour dripper, a 1 liter an hour dripper, and a 0.5 liter an hour dripper on the ridge. On our second treatment, we have 6 liters in each bucket with the same drippers, 2 liters, 1 liter, and 0.5 liters an hour. And on the left here, we only have 3 liters of water in each bucket with the same drippers, 2 liters, 1 liter, and 0.5 liters an hour. If we just take a quick closer look at what the setup looks like, it's a very simple setup. We only have a stool that's about 1/2 meter tall with a small bucket, and then we see a small button dripper at the end, which we irrigate through. After all the buckets has run empty, we allow the water in the soil to distribute a little bit. This normally takes about 24 hours, and then the hard work starts. We dig open all the profile pits, and we physically go and sit and measure at every 10 centimeters, what is the depth, or what is the width, excuse me, what is the width of the wetted area that we see below the soil surface. And then we put it over into a graph format, and this is the results that I will share with you now for that specific trial. So this is the 3 liter treatment, as you can see on top, with all the different delivery rates of drippers, as I've explained to you. And if we take a look at the results, then we can see, like our hypothesis said in the beginning of the theory section, that the lower flow dripper will give the soil the opportunity to distribute the water more horizontally, but we probably will irrigate a little bit shallower. And this is what we see in the blue line here with the low flow dripper, is that we can irrigate a wider area a bit shallower because we want to keep that water and the nutrients in the active root zone. With the higher flow dripper, the 2 liter an hour, you can clearly see that we irrigated a much narrower area, but we went a little bit deeper. On the 6 liter treatment, we see much of the same. Again, please notice how far the water actually distributes below the soil surface. With only 6 liters of water, we already went more than 50 centimeters to one side. So this is 50 centimeter radius below the soil surface. But you can see much of the same, the lower flow dripper going much wider compared to the higher flow drippers, which goes a bit deeper, but much narrower. The last one, the 9 liters, again, the same trend. And I would like to point out as well that if we take a look at the depth, between 20 and 30 centimeters at this stage, after 24 hours, we saw that the water distributed about 55, 56 centimeters to one side. So that's 1.1 meters of wetted diameter that we can expect below the soil surface with a 0.5 liter an hour dripper. Now, if you can imagine, if we put down 2 lines of low flow drip irrigation, which we normally do in an orchard, you can wet a massive area underneath the soil surface without having the losses of an overhead system like micro sprinklers or pivot irrigation or whatever the case may be. We just applying the water and it's being efficiently used below the soil surface. If you look at this results now, you can understand why it is important to do this on your specific field, on your specific farm, to see how your soil reacts. If we have these results, we can really make an informed decision about what is the correct delivery rate, first of all, for your specific soil, and second of all, what is the correct spacing that we want to use between drippers for your specific soil. So we can really make a custom-made setting, I would say, for lack of a better word, for your specific farm to suit your needs on the farm. I like to throw this picture into the presentations because it's always impressive to see a nice root zone. But the aim of this slide is to focus just quickly on how important it is to do proper soil preparation. These are both low flow projects with good soil preparation because they go hand in hand with each other. Soil preparation with correct irrigation, with correct fertilizers, again, you can create a root zone like this. Why am I pointing out the root zone? Because with creating a root zone like this, you are creating potential for yourself at the end of the day. You can just imagine how much water and nutrients one of these root zones can absorb, how many water or how much water, how much nutrients all these roots can absorb. And this all at the end of the day leads to a better yield. A higher yield with better quality crops. So by doing proper soil preparation, by irrigating correctly and by fertigating correctly, you are creating potential for yourself. And I just wanted to point that out in this slide. If we get to the design side of things, I'm going to try and explain the benefits of the low flow system in terms of an example. So on this example, we have 3 farms, farm A, B, and C. All 3 farms are 120 hectares in size. Keep in mind that the daily water requirement for this crop is 3.6 millimeters a day, just for the example that we are dealing with here. If we start switching on the pumps, we can see that on farm A, on all 3 farms, we are in shift number 1 at this stage. And it's important to notice that we have the same size pump on all 3 farms as well. On farm A, we need to irrigate for 3 hours at the application rate of 12 cubic meters per hectare per hour to reach our daily water requirement of 3.6 millimeters per day. Because of the higher flow rate, we can only have 30 hectare blocks. I forgot to mention in the previous slide that maybe for you to better understand what we are dealing with here, on farm A, it would typically be a micro sprinkler irrigation system. On farm B, it would be a more traditional drip irrigation system. And on farm C, we are dealing with a low flow drip irrigation system. So if we continue throughout the day, on farm A, we are already in our 2nd shift. On farm B, we are still busy with shift number 1. And on farm C, we are also still busy with shift number 1. If we continue, On farm A, we're in shift number 3 because we need to irrigate for 3 hours at the flow rate of 12 cubes per hectare per hour to reach our daily water requirement. On farm B, we went over to shift number 2, and on farm C, we are still irrigating in shift number 1. As we go along with the day, we are now in shift number 4 on farm A, B, shift number 2, and C, we are still in shift number 1, as you can see. So if we summarize, at the end of the day, all 3 farms in all blocks still received the same amount of water of 3.6 millimeters per day. On farm A, with the higher flow rates, we had to do it in 4 shifts of 30 hectares each at the flow rate of 12 cubes. On farm B, we had to do it in 2 shifts, each block 60 hectares in size with a flow rate of 6 cubes to reach our daily water requirement. And on farm C, we could have done the whole 120 hectares in 1 shift, in 1 go, because of the lower flow rates. So what I'm trying to explain on this slide is, on farm A, we are constantly driving around, opening and closing valves, making decisions throughout the whole day on how long to irrigate, where to irrigate. It's more difficult to manage farm A than it is to manage farm C. On farm C, you wake up in the morning, you switch on the pumps, you irrigate for the day, you irrigate everything at once, and you switch off the pumps at the end of the day. So I'm trying to explain the benefits of the system and which one is easier to manage or not easier to manage with the different flow rates. And all of them received the same amount of water. If we take a look at something called central pump house control or dedicated main lines, this is something also a new trend that we have a lot of success with. This means that every block has its own dedicated main line that goes directly from the pump house to the block. There's no thing as a big main line going into a sub main line and then going onto the field. Here, the main line goes directly from the pump house to the block. This is nice for a couple of reasons. First of all, you don't need any valves in the field. Everything is inside of the pump house. I will show you a couple of examples now. The second big agronomical benefit is that every block can get its own personal fertilizer and water requirement for that matter. This comes in handy when we are dealing with different cultivars from the same pump house or even different age trees. We know that one development normally happens over a couple of years. We have different age trees, we have different variety trees, and all of them have their own personal fertilizer and irrigation program. And with the dedicated main lines, we can be much more accurate when applying the specific fertilizer and irrigation. And this is where the efficiency of the system comes in again. And everything can be controlled from the pump house. And this is just some practical examples of what I'm trying to illustrate in the previous design. These are both citrus developments. The one on the right-hand side, here you can see all the dedicated main lines moving out to the field. I think there's about 56 or 57 dedicated main lines going out. But there's a few things that I would like to point out in this pump house. First of all, it's very easy to automate because everything is inside of this room. There's no need for radios and wires and stuff in the field that's exposed to vandalism or theft. Everything is inside of this small pump house and you can lock it up and everything is safe. There in the back, the fertilizer gets mixed and it also goes straight through the system, each to his own block. Again, one guy can manage this system easily because everything is together. This is where the efficiency in the use of labor comes in again. Efficiency of time and efficiency of labor, because one guy easily manages between 60 to 100 hectares on a system like this. More on the design side of things, we would like to irrigate the lower lying areas and the higher lying areas together. This is how we do not want it to happen. This is typically a block that's designed to run over a hill from the left-hand side to the right-hand side, from the low lying areas through the high lying areas to the low area again. This creates a lot of problems for us when it comes to filling up the system and draining the system, because every time we fill and drain the system, or drain the system mostly, the water will drain out to the lower lying areas and it will receive much more water than it's supposed to. And we will oversaturate the lower lying areas and the higher lying areas will run on the drier side. This is just to explain what I just said now. Again, every time we drain the system, and this is applicable to any irrigation system, not only low flow or not only drip, but if we design the system to run over a hill from a low-lying area to a high-lying area, we can expect to see problems in the lower-lying areas. So what can we do to overcome this problem? Is we would rather see the design happening so that we can irrigate the lower areas together, S1 and S6, if you can see here, and also the medium-lying areas together, as well as the higher-lying areas together. We also recommend installing capacitance probes or potentiometers to monitor this as well. In actual fact, if we look at it practically, we normally see that in the lower lying areas, we irrigate a couple of hours less than we irrigate the higher lying areas, because we know that the lower lying areas tends to run a bit wetter than the higher lying areas. But now again, with the dedicated main lines and the designs that we do according to soil type and according to topography, we can now very accurately and very efficiently treat the different areas as it is supposed to be treated, and we monitor it as well. Just to summarize the design side of things, I think we can say that one shift irrigates the whole area. I know we can say one shift irrigates the whole area, as we saw in the example that I showed you, compared to 2 to 4 shifts on a normal irrigation farm. The flow rate is much lower. It's somewhere between 2 to 3.5 cubic meters per hectare per hour, compared to a higher flow rate of 5 to 14 cubes per hectare per hour. Again, we discussed the delivery rate. What is considered to be low flow is 1 liter an hour or less, to basically anything higher than that. We are continuously supplying water compared to dumping the water in a few hours, again, as we saw in the example. And this is again where that sweet spot comes in. By continuously supplying the tree with water as it needs, we can fertilizer slowly with fill up. And this is a really important point, because it always comes up in these presentations, is what if we have load shedding, or what if we have a pump that breaks or a pipe that bursts or whatever? We will never be able to get ahead with our irrigation again. This is not true, because with the continuous supply of water with a low flow drip, we never extract more than 15 to 20% of field capacity, whereas with a normal overhead system or micro sprinkler system, you normally irrigate for a couple of hours, you oversaturate the soil, you extract down to about 50% of field capacity, and then you will irrigate again. This irrigation happens 2 to 3 times a week. With a low flow drip irrigation, where we irrigate every day, we do not need to extract so much water, because we're trying to simulate that optimal conditions. So we're trying to be on the top range of easily available water the whole time for the tree to easily extract the water. So we're never running more than 15 to 20% of field capacity. There's less labor and controllers in the field with the low flow systems. We spoke about that at length, compared to more labor and controllers in the field. And this is why we also say that these low flow systems is much easier to manage compared to the more traditional systems that's more challenging to manage. And both will work. It's just a question of which one will work for you. Which one suits your management style best? Which one suits your farm best? Again, we have a variety of products on the market, something that will definitely fit you perfectly, and all of them you will have success with. It's just important to know that you need to understand your specific combination of irrigation with climatic conditions, with your specific soil. And if you understand those 3 components, you will always make a success of your irrigation system. So to summarize, I try to keep it short here. So with low flow drip irrigation systems, we try to keep the crops at optimal condition with water, nutrients throughout the day. Again, the sweet spot that I spoke about a lot today. We also do this with the highest efficiency. Again, the minimal losses to the atmosphere, no evaporation or minimal evaporation from the soil surface, no wind factor taking place as with overhead irrigation. And this leads to more savings of water, electricity, labor, and fertilizer at the end of the day. So these efficient and easy to manage low flow drip irrigation systems means that we are indeed growing more with less. So you're more than welcome at this stage to send a question to the team in Cape Town. I'll be happy to answer them. This is my last slide. So why Netafim? First of all, I really think we understand the farmer's priority, and it's very important for us to also move forward in a sustainable and an efficient way with your irrigation system. We all know that the population is becoming more, it's rising, and the water is our scarcest resource, and we need to look after that, and we can't stress it enough at this stage. So we want to give the farmer the tools to make the correct decision and overcome challenges. And our field team is really equipped to support the dealer network in helping farmers to apply the quality products with the right knowledge for optimal return on investment. This all boils down to our excellent team that we have that has the knowledge to help you with your decision making with stuff like the water distribution test results. How can we help you to make the best decision for your specific farm? Unfortunately, irrigation is not a one-size-fits-all industry. You have to make a custom system for your specific farm, and this is where Netafim comes in. So take on precision irrigation with the right team by your side. And please feel free to visit our Nampo virtual stand. And also remember that we have another presentation on filtration tomorrow morning. Thank you very much.
Thank you, Michael. Thank you, Michael. I think it was a very informative session. We've got a couple of questions. We've got one from Pete. How do you handle water with a high calcium content?
Okay, so it's a good question. It is part of our maintenance routine. So we have a very expansive maintenance guideline book that we normally use within these systems. We have treated a lot of water with high calcium content because we know that it goes and sits in the dripper. So normally for any organic issue, we treat it with the peroxide, and any chemical issue like iron, manganese, and in this case, high calcium, we treat it with acid. So we do a high concentration acid treatment every now and then. Normally the guys do it about 2 to 3 times a year, depending on how bad the problem is. But it is definitely treatable, and we treat it with acid. There are a variety of acids that you can also use to treat the problem. Normally the cheapest one is normal swimming pool acid, which is hydrochloric acid, and we treat it with that. So yes, it is possible to treat it. We deal with it quite often actually, so it's not something to be scared of.
Next question from Anonymous. A lot of people believe low flow drip irrigation can't work in SA as our water quality is too poor. Can you share thoughts about that?
Yes, it is unfortunately something that we need to overcome still. I must say at this stage, we have thousands of hectares of low flow drip irrigation over the country. And like I said, we just in the planning phase make sure that we have certain prerequisites of maintenance procedures in place to make sure we keep the drippers open from day one. We don't want to sit with a problem in 2-3 years time and then all of a sudden start treating the drippers. So we do things like the continuous peroxide. First of all, we also do a water analysis before we even recommend low flow to see if we can see any dangers within the water analysis from a chemical point of view. So we do this to see if we can see any red lights. If we see that low flow can work with this water, then we go on to the next step. We make sure we install continuous peroxide systems. We make sure we install a floating suction on the reservoir or the dam to make sure we suck the cleaner water from the top. And then we also make preparations for if we need to do an acid treatment 2 or 3 times a year. We also write out a very nice maintenance program for the farmer, which involves flushing procedures as well. And then, of course, we make sure that our filtration is up to standard. And this is where the disc filters comes in with the 100 microns of filtration. And again, be sure to tune in tomorrow to the presentation of Leon Horn, because he will explain all that to a very detailed degree. So make sure you tune into that. But yes, it is possible to treat our water, and yes, our water isn't that bad. We manage with that.
Thank you, Michael. Next question: what happens if I have load shedding or breakdown and I can't irrigate for 2 days?
Okay, I think I have touched on this point a little bit. Like I said, first of all, there's 2 factors involved here. First of all, when you have load shedding for a day or 2 and you have low flow drip irrigation, on that 3rd day, you can just switch on the pumps and your whole farm will get water immediately. It's not like you have to go and decide now which block am I going to focus on, what. You can just switch on and everything gets water at once. The other thing is, like I mentioned, is that with the low flow systems, we never deplete more than 15 to 20% of field capacity. So you always have a bit of extra in the tank or in the reservoir below the soil surface. So with normal irrigation systems, we deplete up to 50% of field capacity and we fill up again. With these low flow systems, we only do about 15 to 20%. So you still have a bit of capacity as you would have had with any normal irrigation system as well. So you can stand for a day or 2 and the water and the tree will not stress too much because we have a bit of extras in the tank, a bit of extra water.
Next question, also from Anonymous. Don't the low flow drippers clog more easily?
Yes, again, they are prone, or they can clog more easily if we do not look after it properly. But like I said, if you involve Netafim in your decision making and in your planning, we will help you make sure that it doesn't clog because of all the things that I've already mentioned, all the maintenance, all the good filtration. We know how to handle these drippers. We've been handling them for years now successfully. So yes, in theory, they are supposed to clog a bit quicker, but we take extra good care of them so they don't clog. And I can say this with certainty. Like I said, we have thousands of hectares of low flow drip running at the moment, all very happily and open, still running good.
Thank you, Michael. Next question. Does the high maintenance requirement not cause extra labor needs?
That's a very good question, and the answer is no. In the initial setup, it's maybe a little bit more financial investment that you make because we get a few things in place, like I said, like the floating suction and like the continuous peroxide pump, but we're talking about a few thousand rand. It's not 10,000s or hundreds of thousands of rands to put it into place. When it comes to labor, the answer is no, because everything gets treated from the central point. So there's no need. If you compare the low flow drip irrigation to a micro sprinkler farm, for example, the maintenance on a micro sprinkler farm is much more labor intensive because there's constantly someone driving around, putting up micros, blowing open nozzles, all this stuff. Whereas with a low flow drip irrigation, you are treating all the blocks from within the pump house. So like I said, there's one guy doing a peroxide treatment, there's one guy doing an acid treatment. It goes out to the whole farm. So it's very, very labor efficient actually, compared to other traditional irrigation systems. The only thing that uses a bit of labor is of course the flushing. But this you will have with any irrigation system, that component of labor. And like I said, this only happens every 2 to 3 weeks, depending on your water quality.
Michael, I think you also already gave the answer, but maybe this question, more comments maybe. How do we ensure that we give enough water when we use low flow drip irrigation?
Okay, so first of all, we do the calculations beforehand to see what is the crop requirement for that specific area. We do this with weather station information, and we also do this with the crop factors that we get from scientific reports and from the universities and stuff. So we determine the water daily requirement of the crop, and we work out the system so that we can give that daily water requirement plus a little bit of extra. So like I said previously, it's not like we are giving the trees less water than it can use. We are giving it as much water as it can possibly use. We are just giving it more efficiently. In the other irrigation systems, there's an efficiency factor built in to say that we are willing to let go of 25 or 30% of water because we know we're going to lose it from evaporation from the soil surface and through wind distribution that takes away a lot of the water. With the drip irrigation, all the water that we actually apply gets taken up by the tree. So we're using the water efficiently, but we work out to the millimeter what the tree really needs, and then we take a look at the delivery rates of drippers and the spacing of the drippers, and we custom make your system so that you can give the exact amount that you want to give to the trees. And obviously we monitor it with the probes and with the tensiometers to see that we are on the right path. With the low flow drip irrigation, remember as well that you only use the sunlight hours of the day. So if you feel that you want to add a bit more water, you still have another 12 hours during the night to fill up the reservoir as you want to. So we can give more than enough water. I would also add at this stage that if someone asks me what is the biggest thing that we see with these systems in the field, is that we're actually seeing over irrigation with these systems, because the guys don't see how much water they are actually applying, and then in 2-3 days time we see water running from the ridge because it's oversaturated. So it's a risk to over irrigate with these systems. So we can give plenty of water. I'm not scared about that.
Then we've got a question from Wayne. Can this be used to irrigate teff with gravity feed, but you will have to uplift the lines before cutting?
Yes, okay, so good question. Teff, on the teff side of things, we can probably rather look at installing the dripper lines below the soil surface, as we do with lucerne, as we do with maize, and as we do with sugarcane as well. So we very successfully install the dripper lines 20-30 centimeters below the soil surface. Then you do not have to worry about the cutting. So this is the one option. The other option is that you can install it on top of the surface. Then you need some equipment to just retract the lines before you want cutting. But yes, it is possible to irrigate pastures and teff with drip irrigation, yes.
Also a question, anonymous question. What spacing is recommended with 10 to 12% clay soils and a dripper with 1 liter per hour delivery rate? Maybe Michael, you can maybe elaborate a little bit more on the practical, let's say, guidelines when we speak about spacing in general.
Yes, thanks, Willem. So spacing comes in there's two factors that plays a role when it comes to spacing. First of all, soil texture. So like you said, here now 10 to 12% clay soils. So this is a sandy soil going onto a loamy type of soil. So if we want to wet a strip, we will probably look at about a spacing of anything between 50 centimeters between drippers to about 75 centimeter per drippers. When it comes to drip irrigation as well, we take a close look at the row width of the different crops that we are planting, because at the end of the day, we want to achieve a certain percentage of wetted area. So the row width plays a big role, as well as the spacing of the drippers, because we want to achieve about 15 to 20% of the area we want to wet at the end of the day. If I'm talking about wetted area, 15 to 20% of a hectare we want to wet, and this will be on the tree row. If you compare it to something like a pivot, we are obviously wetting 100% of the area. So there's two things, again, the soil texture and then the percentage of the wetted area that we want to do. And this is where we make a decision on what is the correct spacing between my drippers. But if just by hearing the texture of the soil, I would probably recommend something like a 60 centimeter spacing with a 1 liter an hour dripper for a soil with about 10 to 12% clay.